Assalamu alaikum. Welcome everybody. Live class on water chemistry with Jakir. আশা করি সবাই ভালো আছেন। আজকে আমাদের day 9. We'll talk about dosing and we'll see chemical dosing for WTP, especially RO. I'm waiting for the people to connect. And let's welcome everybody. Please, if you hear me clearly, if you can see my video or you can see my screen, you can comment so that I can understand things are all right. So thank you who already connected, and I'm waiting for more people so that I can start. Thank you. You can write your comment from where you're connecting, and you can also give feedback how you feeling. I'm waiting for a minute for joining other people. Thank you. Please comment from where you are connecting and how you are feeling this class. This is a 9th class. Welcome Zubair Rahman Russell, Asif Iqbal. Hope everybody doing well in this stress corona time. We all like to spend our time in a very productive way, and we also like to keep ourselves energetic, and we want to make our life beautiful. Thank you Palash for joining. Hope you are doing good. Please whoever joins, share or you can play watch party to your other friends or your people who like to watch this. And this is very important class. Usually this kind of discussion it's very rare. I'm trying to share my experience. Last 15 years I'm getting from practical scenario from Bangladesh. So whatever you are watching, please share with your colleagues, share with your team. I'm just waiting for a few more people who wants to join, and they are joining. So as you connected, please share and tag your friends who actually need to join here. And you can write from where you are connecting, and if you have any feedback, please don't hesitate to share. I'm waiting for more people. Welcome Nurujjaman. Thank you for joining with us. Today we will discuss regarding the chemical dosing for RO plant, and we try to show what are the chemical used for RO process and how we should calculate the dosing, and how much chemical we should set for a particular project. So many of you already joined, and some of also will join. So today I like to start with an story. I'm reading every day whatever I can, and today I learn a small story I like to share. And I also actually watched a lot of different people video, and I saw again remind me Mr. Ayman Sadi. I saw his video also. He is saying a story of Warren Buffett. He is the world best investor, and a lot of people get, even the big billion-dollar people also go to the Warren Buffett to understand how he do it. So the simple story: Warren Buffett asked a guy, if you want to have a car, and this is only the car you have to use for a whole life, so what car you should have, or what car you like to have? So many people reply, I like to have a very beautiful car. Then he asked, how you take care your car? So he replied, yes, I do take care the best possible. I use the best fuel, I use the best maintenance, best lubricating oil, and many things. Then Warren Buffett says, very good, thank you very much. Just look at your body. The body you are carrying, this is the only vehicle, this is the only machine, this is the only car that you carry whole life. So please take care on it. It's a very nice story within the corona period. We all are at home. We are doing a lot of other things. Maybe we are getting lazy. Maybe we are getting up late. Maybe we are eating more. So please, I just remind you all, please take care of your health. This is the only engine you will carry with you for whole life, guaranteed whole life. Nothing else, no other engine, no other machine, no other laptops, or no other things that you will carry whole life in single things. Even if you have a beautiful house, you might have another house in your life. If you have a beautiful car, you might have another car in your life. But this is your physics, this is your body, and this is your mental machine. I'll talk some more on later. And even you can watch the group that is called Restart Yourself, conducted by Javed Bhai. I always watch his video. He conducting a live call that is Restart Yourself. So a lot of good stuff over there. You can learn about your life and how your life should lead. So today we are coming to my topic. So today is basically water chemistry. Thank you all who have already joined. Mahbub Alam, Golam Kibriya, Ahmed Arif. I just request you all who join, please share on your wall or share with your friends so that other people also can watch. This is very important. Today I will discuss very important class. We will discuss the dosing calculation for RO plant. Saifuddin, thank you. Feroz Alam, thank you. So many of us actually from water treatment, and a couple of people I observed, they are actually not in water treatment. So we also know that people want to know water. I'm very open for everyone. So I keep the presentation, the discussion sometime a very nice and easy way so that everybody can understand. So I'm sure the majority people who join, you know what is a RO system. The picture showing a RO system. So basically RO system is nothing but with a pre-treatment, and it goes water into a RO membrane and come out the water. Today's discussion is not about RO. Today's discussion is about RO dosing system. But still, for many people, even doesn't know what is RO. So if you have any question what is RO, you can write on comments. I can catch you on the comments later. But still, for many people, I like to give a small video to what actually RO look like. Please enjoy the video and watch it. This is available on internet. If you watch it, it is self-explanatory what is RO and how it is structured. Just after that, it's a 4-minute video. After watching the video, I will come back for the dosing calculation. So now I am keeping stop talking. Please watch the video. Thank you.
The St. Mary's Water Recycling Plant uses reverse osmosis to further treat wastewater after the ultrafiltration process. Reverse osmosis membranes are constructed from a membrane flat sheet. It is comprised of 3 layers: a polyester fabric support base, a microporous polysulfone layer, and a 0.2 micron thick polyamide barrier layer. The polysulfone layer strengthens the very thin barrier layer. It is the barrier layer that removes nutrients, chemicals, bacteria, and viruses from the water. Membrane flat sheet is combined with a sheet of feed channel spacer. This provides turbulence and creates space between the membrane sheets for the feed water. A sheet of permeate spacer is added to the membrane sheets and feed channel spacer. This enables the final recycled water product, or permeate, to flow evenly across the entire membrane surface, even under high pressure. The back of the membrane is completely sealed to the edges of the permeate spacer. The membrane sheets are glued along each of the 3 exposed sides and rolled around the core tube. Feed water is forced through the feed channel spacer and into the barrier layer of the membrane. Water passes through the membrane surface into the permeate channel. It flows in a spiral direction and collects in the core tube. This water is the final recycled water product, or permeate. There are 7 spiral wound elements loaded in one pressure vessel. Once the end adapter is connected to the last element and the pressure vessel is sealed, feed water can be introduced. Feed water is pumped at high pressure into the vessel. As it travels, small molecules like water pass through the membrane, while larger particles such as salt, bacteria, and viruses do not. The final recycled water product is collected from the end of the elements. The concentrate or reject from that vessel flows to another stage, producing more recycled water. At St. Mary's, there are 6 reverse osmosis treatment trains, each with 3 stages. This design produces the highest amount of recycled water with reduced concentrate waste. Stage 1 has 52 pressure vessels, Stage 2 has 24 pressure vessels, and Stage 3 has 12 pressure vessels. 58 million litres of feed water enters the reverse osmosis system on a daily basis. As the feed water passes through each stage, more recycled water is extracted. 65% of recycled water is extracted at Stage 1. The remaining 35% is passed through Stage 2, where a further 10% is extracted. The final 25% is passed through Stage 3, where the last 5% of recycled water is extracted. 80% of all feed water is recovered as recycled water. An average of 50 million litres of recycled water is produced every day at St. Mary's. The remaining concentrate contains so much salt and impurities that to recycle it would not make economic sense. This concentrate stream of 8 million litres a day is sent to North Head Wastewater Treatment Plant, where it is treated and released into the ocean.
So thank you very much. You already watched how RO look like and how RO works. Today our topic mainly discussion of RO dosing calculation. So especially maybe you already know what are the chemicals usually used in RO plant. If I like to give it at a glance, usually there should be a bleaching and oxidant agent like Hypo or Chlorine. Yet there should be an acid or pH adjuster, maybe before RO feed or after RO, depending on the purpose or application where the water will be used. We have to use chlorine scavenger, can be SMBS, sodium metabisulfite. Then we have to use scale inhibitor or anti-scalene chemical. We have to use sometime biocide, biodispersant, and we have to use CIP chemicals, the low pH cleaner and high pH cleaner. So these are the chemistry that we have to use for RO system. So if we want to understand the dosing of each of the chemicals, I like to give you all a brief and at a glance in a short time. But please, this is a process, this is a way out I like to share with you. The number, the percentage, the unit may use in my space is not identical, is not applicable for everywhere, is not applicable for all the plant, depending on the design, depending on the feed water, depending on the chemical available, depending on the environment. All should be used independent design amount of calculation. Thank you Tuhin Burua Vaya for joining. So if we see the chemical usually that we use like Hypo, depending on the organic load, depending on the chemical or other things present in our raw water, we have to select the Hypo, bleaching and other things. Engineer Muhammad Ishfaq Gujar, thank you very much for connecting. So depending on the percentage of chlorine available in the Hypo or chlorine or bleach material, we have to consider this. And we have to set how much free residual chlorine we want to maintain after the chlorination dose or before the RO. So we have to set this residual amount, and we have to know the RO feed water and running hours in a day. So if we know all these parameters, we can calculate the amount of Hypo or amount of chlorine. So we consider here Hypo. So just let's see what is the dosing and how we can calculate the dosing calculation. This is a way out. Again, I am just giving the way out. This is not the unique, or this is not identical for every plant. So if you want to calculate the Hypo, we are considering free residual chlorine 0.5 ppm we like to maintain. And usually the Hypo we have or available in our plant, it might have 7% chlorine as a fresh batch. And if it is Hypo stock is older than more than 15 days or in a month, we have to check at laboratory what is the actual percentage of free chlorine in this Hypo. And practically the wise decision is we should make the trial. We should make the trial with the Hypo dose. How much ppm Hypo I need to maintain the residual phosphate, residual free chlorine 0.5 ppm. So for example, a practical trial give us the result 50 ppm hypo give after consumption 0.5 ppm free residual chlorine. So if we think we have to dose 50 ppm, then the calculation will be for 20 meter cube per hour and 12 hours day operation. So 12 into 50 divided by 1000, it will be 12 kg per day. So this is simple way to calculation, but before calculation we have to know all this parameter. The challenge is all the information sometimes is not available or sometimes difficult to calculate. So still, if we have to arrange all this and we can calculate the hypo amount very easily. So here is a red notation, red note is below. Hypo quality is very unstable and 50% lost after 30 to 40 days. So this is very critical for hypo. We have to use the daily laboratory analysis report of the hypo or weekly analysis report of the hypo to confirm the dose and to confirm the right amount of dose. So second product immediate after hypo we have to use for RO is, as RO membrane is susceptible for chlorine, so we have to remove all chlorine from the feed water of RO. So we have to use the chemistry that scavenges any free chlorine remain in the system, and that is scavenge we use that we call usually popularly use sodium metabisulfite. So many other chemistry also available, but here for calculation we consider SMBH. So if we want to calculate the amount of SMBH, we need to know very clearly how much the free residual chlorine available in the RO feed and the purity of the scavenger, the SMBH the purity, and the RO inlet parameter and running hours. So if we have all this information, we can make the calculation. For considering residual free chlorine 0.5 ppm maintained in feed, so an SMBH purity is 90%, active purity means active ingredient in 90%. For just thumb rule, for easy calculation and thumb rule, we consider 1 ppm SMBH neutralize 1 ppm free residual chlorine. So practically 0.5 ppm free residual chlorine need 0.5 ppm SMBH to keep some surplus, so that free residual chlorine will not be available. So we consider dose is 1 ppm for SMBH. So for the 20 meter cube and 12 hours, it becomes 20 to 12 into 1 divided by 1000, 240 kg per day, means 0.240, means 240 gram per day. So the important things is the tank solution we must make below 10%, and if we make the solution we must finish this by 5 days, guys, by 5 days. After 5 days the solution expired, solution effectiveness reduced. So if you have any questions so far, please write in the comments, we can discuss. I'm sure you are with me, right? Tuhin Burwa Bhaya, I think you can understand what I'm talking. Today is our 9th class, and we have previous all 8 video class at our group, and you can watch it, and you can please I request you all, please like the page and share this page to other people, so that you can share your colleagues, you can share your juniors who are working with you, so that they can learn and easy for them. And if there is any question, it is open for all, you can ask any question, we try to discuss. So I'm coming to the point. So first, RO dosing calculation, we have to calculate the hypo. Second, we have to calculate the SMBH. Third, the things that we usually use in RO, that is anti-scalant. As our time is limited, I like to close by 11, so I want to go fast. But if you have any question, if anything you don't understand, please write and I will try to explain or reply on comments. So third product that we use usually is scale inhibitor or anti-scalant. So now we like to see how we can calculate the anti-scalant. So anti-scalant calculation, we need some information like the mineral load. What are the critical ions here to control or to create a scale, like calcium, iron, sulfate, or what are the ions that can create a scale? So you have to understand the mineral load. We have to see the COC and salt rejection. That means it also helps us to understand the salt or load. Depending on the this, we have to select the chemistry, and we know the chemical active ingredient. we have to set the residual amount of the chemical, or it may be the phosphate, or it may be other polymer. We have to understand, we have to get that data for residual amount, and we have to understand the product PDS, the actual product we selected. The PDS will give us the idea how much ppm dose I should dose for this particular product to control a particular mineral scaling. So if we have all this data and we have the RO flow rate and the running hours, we can easily calculate the RO antiscalant dose. The dose is simple, 12 meter cube per hour, 12 hours in a day, and if I consider 10 ppm, and it becomes 2.4 kg per day, and this 2.4 kg should not be the solution. We should not make more than 20%, and we should finish this by 3 days, because after 3 days this kind of chemical solution efficiency get reduced. So I think this is very easy for you can calculate the RO antiscalant. So if you have any question, please put on the comments and we can reply later. So next, the product that we usually use for RO plant, that we use biocide or biodispersant, depending on my RO organic load, RO fouling tendency, depending on my hypo activity, depending on my pre-treatment, we might need to use biodispersant or biocide dose. So for biocide, we have to consider the organic load, we have to consider RO on-off trend. Sometimes we keep our RO off and on, and sometimes we keep off for maybe 1-2 days or more days. So the RO plant that are under off condition, the more frequently the off, the chance of organic fouling will be high. So for that case, we have to use biocide and biodispersant. So if you have the RO feed flow and running hour, we can easily calculate the RO requirement of biocide and biodispersant. So thank you Humayun Kobi for connecting. So for biodispersant calculation, we just use the flow rate, like depending on the flow rate, depending on the product, if we consider for biocide 100 ppm for 20 meter cube per hour, so it becomes 2 kg per dose, and for dispersant if we consider 10 ppm, so it becomes the 0.2 kg per dose. So you can dose this as a shock dose, and we can just prepare the solution, should not be above 20%, and we can dose once in a week or once in a 10 days or once in a 15 days for certain hour, depending on the available facilities. So this is how we have to calculate the biocide or biodispersant. The rest product that we have to use, that pH adjuster, either we have to acid or we have to use alkali, depending on the pH of the before RO or after RO, we might have to adjust the pH. So if, like, considering the after RO water, the pH might be low, or before RO water pH might be high. So if our pH is high, then you have to use acid to reduce the pH, to control the RSI or control the LSI. Better low pH, less chance of scaling, we know that. So we have to maintain the acid, dose the acid to reduce the pH. Sometime after RO pH get reduced, so depending on the purpose where the water is used, we have to use alkali to increase the pH of treated water. So both the case, we have to use either pH adjuster, means either acid or either alkali, if we want to increase the pH or decrease the pH. So how we do calculate for acid or alkali, here at a glance you can see. For acid calculation, we have to check the alkalinity, and we have to check the pH alkalinity table, how much pH I like to maintain and how much alkalinity should be there, and what is the current alkalinity. So I consider here I have to reduce alkalinity 20 ppm, and the acid available to me, I consider hydrochloric acid, and it is 30%. So if it is 20 ppm alkalinity, I have to reduce, I consider 1 ppm per ppm of alkalinity. So if I want to reduce 20 ppm alkalinity, I am using 20 ppm hydrochloric acid. So thank you Tuhin Borua Vaya, you asking me a question that RO keeping long time. So it is really a good and tough and professional job to keep RO perfectly all right for long time. I'll come back to you later on your comment. So today I just sharing the dosing calculation. I will come back to you Tuhin Borua Vaya. So here the things I'm talking, that if I want to reduce 20 ppm alkalinities, then I have to dose 20 ppm of hydrochloric acid. So it is, if it is 20 meter cube per hour, 12 hours, so 20 ppm, so it becomes the calculation. And if it is 30% impurity, so the formula is you have to divide it by the purity percentage, so it becomes 16 kg in a day. So for this process we have to use 16 kg per day. If the density is 1.1, it becomes 14.55 liter for this. So the tank solution should be lower than 10%, and if we make a solution, then solution must finish by maximum 5 days. So similarly, if we want to calculate the alkali, means if we want to increase the pH after RO, sometime we might require to increase the pH. I'm just considering I have to increase the alkalinity 10 ppm. The alkalinity solution I have, that is 40% active, and thumb rule is similar, 1 ppm per ppm alkalinity. So if I want to increase 10 ppm alkalinity, then I have to dose with the 40% active ingredient. I have to dose similar 20 into 12 into 10 divided by 1000 into purity, so it becomes 6 kg per day. If it is a caustic kind of solution and the density is 1.4, so it becomes 4.3 liter per day we have to use to increase the 10 ppm of alkalinity. So this is the way out how to calculate. Please do not consider my calculation as identical, can be used for any plant. It is not at all. You can't use this for any plant. This is a thumb rule. This is the way you have to calculate according your availability, according your plant, according your alkalinity reduction or increase. Please take it as a just a guideline. So finally, after running RO certain time, we have to go for RO CIP. There's we have to do some cleaning, online cleaning and cleaning process for the RO membrane. So during the cleaning process, we have to use two kinds of chemical that we call low pH cleaner and high pH cleaner. And on the high pH and low pH cleaner, we have to select the dose, and depending on the fouling, we need to select the chemistry, we need to select the chemical, and depending on the RO manufacturer guideline, there are a lot of different company and different chemical we can use. So we have to understand what are the fouling happen. It is inorganic, organic, or what are the fouling. So depending on, we have to select the product. We have to know the active ingredient of the chemical, or we have to know the dosing amount from the supplier. We have to understand the OEM advice, and we have to understand also from the product data sheet how much percentage they prefer to use. So if we have all the data, and you have to understand the CIP tank capacity, here consider 1000 liter, and CIP flow, here consider 20 meter cube per hour. So if you have all the data, we can calculate the CIP dosing calculation amount. Very simple. Usually we have to dose at CIP tank, so we have to consider CIP tank capacity. If I consider 2% chemical dose, then 1000 liter in 2% the 200 kg per circulation. So I have to use 200 kg chemical and make solution for 1000 liter, and I have to recirculate this solution. Usually first we have to recirculate high pH cleaner, then we have to circulate low pH cleaner as a safety. So tank solution should not go above 5%, and if we make the solution, we should do the work one day, or we can keep the solution maximum 2 days for its efficiency. After 2 days the solution efficiency get reduced, so we can't use this. So this is the things, that is RO calculation, RO dosing calculation. So if you have any question on this, please pass on comments. And this is our 9th class on water chemistry, and I will keep it continue. Tomorrow I will come on that more dosing calculation regarding the especially cooling water treatments, and after that we will go for boiler water treatment. So today I finished the RO dosing calculation formulas or some tips and tricks. If you have any question, please put on comments. I request you all, please share this group, please share your friends, colleagues and the surrounding, so that many people can connect, and we can create a water treatment community, and we can enjoy the lot. So my sincere request to you all, please take care, make your health very good engine for you that you use a lifetime. Take care of your health, take care of your mind, and this is my request. Do reading something, watch some related professional video, do write something. You can work in many area. So my sincere request, you please take care of your health, and I think that's all for today. If you have any question, please write on your comment. Thank you very much. Take care. Assalamu alaikum. Bye bye.